All right. Hello, everybody, and welcome to the stream. Hope everybody's doing well tonight. Tonight we have a little bit something different on the roster to get done. But before we jump into that, I want to just take a quick second and thank the supporters of the channel. They are all the folks here listed on the screen. These are, starting with our partners, they're the highest tier of subscription over on Patreon and YouTube memberships. They are Gebby Bashir and Gorboli's Inc. I'd also like to thank the other supporters listed here on the screen. They are the other tiers of subscription over on Patreon, YouTube memberships, and Twitch subscriptions. Thank you all very much for your support. It is greatly appreciated. And I hope it goes without saying that I appreciate each and every one of you viewers, whether you're over on the Twitch side or whether you're on the YouTube side. I do keep an eye on both sides. We do simulcast, so thank you guys for being here. I appreciate each and every one of you guys who's following along, participating, kind of giving me updates as to what you're doing and whatnot. I appreciate you guys. So that being said, this is an interactive stream, so I do keep an eye on the chat on both sides. So if you would like to chat, as long as it's, semi-related to the stream or whatnot, feel free to jump in. And if you have any questions or whatnot, feel free to ask them. I will answer them to the best of my ability. Let's see. Smudge, hello, good evening. Good to see you. How are you doing? Well, I hope. All right. So tonight we're actually going to do something a little bit different.
Good evening.
Diamond, thank you for the TTS and the resub at tier 1 for 3 months. Thank you. I appreciate that. Appreciate the support. Thank you. Hope you're doing well. All right. So tonight we're going to kind of proceed in a little bit of a different direction. I know last time we were kind of playing around a little bit with potentially a scripting or a console language, right? Or like a lightweight scripting language. I've decided I'm going to table that for right now, simply because there are other much more important things that we need to do and get knocked out. So I'm going to pursue those instead. However, the code is not lost. I did actually just kind of disable most of it and push all of it into the 0.6 branch. So everything that we did in there is in place. It's just not currently active, right? Let's see. Good, been going through the engine series and writing in C++, and I slowly realized myself doing things C style, so you decided to rewrite in C for fun. Awesome. It is good practice, yep. Yeah, that was kind of the, more or less the thing that I found as I was writing my projects. It was kind of like C++ light or just kind of C, right? So, yeah, it looks like you're kind of going the same path as me. Max, hello. How's it going? Let's see. The video description on YouTube doesn't have the Patreon link. You know what? You're probably right about that. That's a dang good point. Do I have... I do have a link tree, though. And that does have it. So I'll drop that in chat. I should go ahead and add that to the video description. I don't actually know how to do that from the current screen that I have open here with this sort of stream in it, so I'll have to figure it out afterwards. But what I will do is write it down. Thank you for bringing that to my attention. I appreciate that. Okay. Yeah, if you guys notice anything like that, whether it's, an inconsistency in a link or something I've done on screen that's dumb code-wise or something like that, feel free to bring it up, right? I appreciate it. All right, cool. So let me just go over, and I'm actually not even going to go into all of these, right? I just kind of want to touch on some of the recent commits that we made because we fixed a couple bugs off camera. And so I didn't want to, sort of leave those as is. So I added a missing peak function to our stack container. so that we could actually peek on stacks. That's the change log change for that. The actual change is here. So yeah, this is all the stack peek is, right? It literally does the same thing as pop, it just doesn't remove it, right? It's read only. So there's that. We fixed a couple of bugs where the SUI label wasn't updating the vertex index buffer offsets correctly. And then actually there were a couple rounds of fixes for that. So I'm not going to step into those because there was a little bit of refactoring that was done in there. You guys can just kind of have a look at those commits if you're interested in that. It's not particularly entertaining stuff or worth going over on stream, I don't think. Same thing goes with this label geometry regeneration. They all kind of, everything here that's SUI label just kind of falls together. There was also an issue where the shadow projection matrix was not using the directional light properties that I fixed. So I've just kind of fixed a couple small things off camera, right? But other than that, not much else has gone on. Let's see. Zang44, first time chat, so welcome. Thanks for making these interesting streams. I'm glad you find them interesting, and thank you for being here. I appreciate that. And welcome to the stream. Glad to have you here. Let's see. Pete's Astrophotography. Hey, I love your videos. Just getting back into game / engine dev after a long spell in the oil gas industry. I come from the ST Amiga and I love the low level coding style. That's awesome. Honestly, I'm a bit disappointed that that I never really got to experience the Amiga, right? Because everything I've heard about it basically indicates that it was an awesome platform to develop on. So that does bum me out a little bit, right? One of these days I might have to just see if I can actually find one just to actually try it out, right? But yeah, welcome. I'm glad to have you here. All right. So let us get this out of the way. And we'll bring down our buddy Vim. And like I said, tonight we kind of want to take a little bit of a different direction and kind of start knocking out some things that are in our to-do list here, because we need to actually start kind of thinking about getting this ready to make an actual game with, right? So some of the high-level things that I want to hit are batch and instance rendering. Those are definitely going to be needed to be done. I would like to get this per scene vertex index buffers up instead of having sort of a global one that everything sits in. I would like to have different sets of those for different things. This one I'm not so worried about. Some of the shadow stuff I'm not as worried about, right? We can always add those things later. ECS I'm not worried about. I don't even necessarily know that I'm going to get to the multi-threading stuff yet either, right? We might not actually tackle that before we actually start making a game. The standard UI stuff I don't think I'm going to tackle either. Nor the editor, right? We can make our first game without an editor. I think that's fine. And that'll kind of give us an idea of what we need, what would really be handy in terms of an editor. So I'm going to kind of skip that too. What I want to cover tonight is actually one of these items that we've added here. And the reason I want to cover this is because basically what we've got is we've got a forward renderer right now. And all of our configuration for that render graph sits in our testbed library, our sort of test application, which is not ideal. And really what we want is a sort of specialized render graph that contains all of this stuff and sort of works under the hood, and then we just have a few places to hook it up in our application to actually utilize that. And that way, we can kind of simplify our application code, right? Because our application code right now is almost 2,000 lines of code. Now, granted, some of this is like commented out stuff, right? So there is quite a bit of dead code in here that we can get rid of. All of this, for example. But we've got all this render graph pass configuration here. But then more importantly, in the prepare frame, we have a heck of a lot of logic in here that really should be moved off elsewhere. So my thought is, that we really ought to containerize all of this stuff in a sort of specialized render graph. And a specialized render graph is essentially just going to be a wrapper around a render graph that includes configuration and configuration-specific logic that needs to happen. And so the other purpose in doing this is right now we do have forward rendering, but we are eventually going to do deferred and forward plus. And it would be really nice to be able to use either a combination of these things or choose one to use at the application level, and it just kind of works, right? Instead of having to do all of this stuff that we're having to do in here. So that's the goal. We want to move a little bit closer to that. So that way, when we actually go to stand up our game application, we don't have as much of this stuff to actually stand up. So that's what we're going to do first. And then the other advantage to that is as we develop more features for this, we can just kind of add them in here to that forward rendering graph, right? Okay, so with that said, since we're tackling that, let's see, where do we want to put that? Because we have the render graph sits under the renderer. So I'm thinking it actually kind of makes sense that maybe under the renderer, where we have this passes, maybe we have like specialized graphs, or maybe we just call it graphs, right? Or graph types, and roll with it that way. Maybe that's how we do it, right? Cry, good to see you. Hello, welcome to the stream. Glad to have you here. So yeah, let's go ahead and let's do that. Let's create under the renderer, and this is the renderer front end, right? Let's see, we have the individual passes. Let's do graphs. I guess will be the folder, right? And then to this, we're going to add forward graph. I guess that's what or maybe we'll do forward render graph .h. And we'll also add another one, forward render graph C. And then, the other types that we create, we'll just kind of create alongside this. Let's see. What exactly is a scene responsible for, or is it a container for scene data? So yes, it is a container for scene data, but also it's eventually going to manage things like spatial partitioning, so like quad or oct trees, things like that. It's responsible for doing things like sorting based on distance from the camera for like things like transparency, where we have order dependent transparency, things of that nature. So it's also responsible for managing the life cycle of objects within it. So kind of encapsulates all of that stuff, right? And so the scene doesn't really know about like the scene, for example, wouldn't know about an ECS, for example. An ECS would reach into the scene and interact with objects through the scene, right? But the ECS doesn't exist as part of the scene. It's where the scene graph lives, right? So you have that hierarchy of objects. And then it also has, so it maintains not only that hierarchy, but the transform hierarchy, as well as, object sorting, things like that kind of thing, right? All of those things. And probably more as we go on. There will also be a concept of like, what's the active camera versus, all the cameras in the scene. So the active camera would be the one that's currently in use by the user or the player, right? It would manage that as well. Right now, that's kind of managed during our game state, but eventually that'll be changing as well. Okay, so let's open our forward render graph. We'll do pragma once. We'll probably need to include renderer, render graph for sure. And then I guess let's kind of start speccing this out a little bit, right? So prepare frame is probably not the place we're going to want to start looking. So initialize, let's see, where do we actually create? Okay, so this is prepare frame, resize, register events. Let's see, refresh render graph pointer functions, configure render graph. Yeah, so these are all the kind of things that we're going to need to kind of consider. Okay. So I think the first thing to do is we'll type def a structure, and we're going to call this forward render graph. Right? We'll just make it have its own type. Because it's really going to serve as sort of a container to the actual render graph. We'll do struct. Actually, we'll just do render graph. Graph. Let's see. So we have frame graph here, which is not really a good name for it, but let's peek definition on that guy. So here's all of our passes, right? So we'll need to actually move these over. We need to move our shadow map resolution over. Maybe our viewport information. I haven't really decided on that. But here's the other thing that I was thinking as well. So right now we have a skybox pass, a shadow map pass, and a scene pass, and an editor pass, which is like what draws the gizmo and that kind of thing. And then we have UI pass, right? So if we think about like the UI pass isn't really part of a forward renderer, right? It's kind of its own thing. And so we might wind up having like a separate specialized container just for that, I'm thinking. And then maybe we have the capability of render graphs to depend on one another, right? So maybe we have more than one render graph, which is kind of what I was thinking about earlier. And this, I think, makes the most sense, right? Where it might make sense for us to maybe include everything in a single render graph. The UI doesn't really fit with a forward renderer, right? So I think what I'm going to do is take everything except the UI pass, right? And we'll put that here, and we'll get rid of this frame graph, right? Because we're just going to call it graph. And then, let's see. So we have all this, all these other things in the state that we don't necessarily need as well. So we have and actually technically the editor pass doesn't really belong in there either if we think about it. So let's actually strip that out as well. Let's put that back here. So really it's our skybox pass, our shadow map pass, and our scene pass that are important right now. We're going to have others as well. And then this kind of stuff happens on top of that. And I'm also thinking we might be able to do some stuff with the editor pass differently as well. So we'll kind of see where we land on that. Let's see, what else do we have in here? So we have the gizmo, which is kind of part of the editor. We have our test lines and test boxes, which are kind of like debug geometry, if you will. So I don't think I'm going to move those. Let's see. So UI meshes and that kind of thing, that's fine. I don't think I need to actually move any of this stuff. I think all of this can be passed as function point, or as parameters, as pointers, right? I don't think we actually need, maybe width and height, maybe. Oh, shadow map resolution. That should probably be in here. So take shadow map resolution. Render mode, I think I'm going to keep here as well. Okay. All right, so I'm satisfied with that for now. So these are basically the things that this is going to encapsulate for now. So the next thing we'll need is we'll have to export this, right? Because we need our application to be able to call it, and this is core engine code. So we're going to do B8 forward render graph create. Do we want any kind of config? I think we should probably have a config object. Let's type def a struct forward render graph config. Forward render graph config. And actually, shadow map resolution can be in there. We need something, right? And so the first thing that we can do is we can do a forward render graph config. Let's see. Let's turn this into a const pointer. And then do, whoops, let's do a forward render graph pointer, and we'll say out graph. Okay. And then we'll export the destruction of that as well. So that's going to be a void pointer, or just a void rather. Forward render graph destroy, if I can spell it correctly. And all this is going to take is a forward render graph. And then we have the other parts of the life cycle, right? So we have forward render graph initialize spelling. So this will be forward render graph. Not sure if we're going to need anything else for that, so we may have to add to that. Then we have a update, which is also going to need frame data. So struct, I can't spell tonight apparently. Struct frame data pointer p frame data, which means we also need to forward declare that. Struct frame data. All right. Make sure I'm not coding behind my head here. There we go. All right. In fact, let me actually just quit. Actually, I'm just going to actually switch these two windows now that you think about it. So put the render graph over here. Test main. Let's see here. Okay. So we have our updates that takes in our frame data. That should be sufficient there. We are also going to have our frame prepare, which I think just basically takes in the same parameters. And I think, oh, we need a resize as well. Let's see. So we need, yeah, U32 width and height. Forward render graph on resize. Forward render graph, and then U32 width, U32 height. Okay. I think that's all we need for right now, scaffolding wise. Let's see. So render graph is a description of some work to be done, yeah, more or less, yeah. So it contains all the data about our passes. It's responsible for gathering all of the data that needs to be handed over to the renderer to actually render the frame. And then it's also responsible for starting and stopping the render passes and all of that, and hooking all those things together, setting up all the attachments and all that good stuff. So a render graph encapsulates all of that. And then what we're doing here is we're basically taking the configuration of the current render graph that we have and all of the work that it's doing, because we essentially have a forward renderer render graph set up right now. So we're basically taking that and wrapping it in this package, so that we can just minimize the amount of actual application code that we have to have in place to do all this. So I suspect in doing this, we'll also see some things that we probably need to move around, which is not a big deal, but let's see. Is it actual forward or forward plus? So right now it's forward, but we do have on the to-do list, we do have deferred and forward plus on the to-do list. So that's part of the reason I'm doing this as well, because I want the ability to have a forward renderer, but I want the ability to be able to switch between these just by using sort of a different specialization and not having to set all this stuff up. With that being said, because of the way we've architected it, if you don't want to use these and you want some other sort of custom render graph, you can also set that up. Yeah. So this just kind of puts everything into a neat package for convenience, but if you still want to do it manually, you still can. Okay, so let me take all of these and go into the C file. We'll include forward render graph. Put all these things in there. All right. Okay. So essentially what we're going to do for right now is more or less move everything that is in the test bed right now over here for these different aspects of the life cycle. We're going to have ads in a minute too, so I'll be sure to keep an eye on that. Let's see. So the render graph drives the renderer like a driver, basically. Yeah, more or less. Yep. Yeah, so it's the one that gathers up all of the data to be submitted to the renderer and then actually submits that to the renderer. So our render graph basically has this life cycle. So we have initialize, where we kind of set up some configuration stuff, but haven't loaded any actual resources yet, like textures and things like that. Then we have load resources, which actually stands up those resources, like from the GPU and that kind of thing. We also then have a execute. So execute is basically execute the render graph that's been configured. Destroy, that's pretty obvious. And then we have some function pointers down here for texture regeneration for things like resizes and stuff like that. But yeah, the main life cycle of it is within these four functions here. Yeah. Hope that makes sense. Okay, so I'm debating if I want to move this viewport stuff over. I don't think I do. I think I want to provide that via calls to this. This is UI stuff. So really this render graph on resize, I think, is the only thing that we're going to wind up doing. So that's an easy one. Does this actually return anything? It does. So we're just going to do this. We weren't even checking that before, which is dubious. Graph. Oh, we have ads. So for those of you who are new to the stream, on the Twitch side, we are served ads once every 30 minutes for 90 seconds. And what I'd like to do is, whenever that comes up, I like to pause the stream so that nobody misses content, because you can't see or hear what's going on, and on a programming stream in particular, that's not great, right? So out of respect for the viewers, I like to pause the stream until those ads are gone. Depending on region or locale, some people get the full 90 seconds of ads, some people only get like 30 seconds of ads, and some people don't get ads at all. And I know ads work a little bit differently over on the YouTube side, but you know, just to cover all of our bases, I like to go ahead and pause. Also gives you guys a quick second if you need to run and do something. You've got 90 seconds to do it, and it gives me a chance to hydrate. So it's not always a bad thing. So let's see, we've got about 15 seconds left on ads. And Rocco on YouTube, I will answer that question in just a second as soon as ads are dead. All right, ads are dead. So render graphs are more or less a blueprint / layout describing how things are rendered. Correct. Yes, that's 100% correct. So that's basically the idea of it, right? Is having something that allows us to configure the way things are rendered in a standardized way, so that we don't have to like do low-level renderer calls all over the place, right? Let's see. Maybe a bit premature, but are you planning on going for clustered or tiled or both forward plus renderers? We're going to play around with it, right? We're probably going to wind up doing both. Because I know that some of those things work better on some platforms than others, right? Like tiled, for example, is better on mobile, if I recall correctly. So we're going to play around with some different configurations on that. More than likely, clustered versus tiled will be a configuration option for the forward plus render graph that we set up. This is probably how I'm going to do that. So we've got this sort of generic configuration object that we can pass to each one of these things, and that's kind of how we're going to set it up, right? Okay, so here we need graph, graph.graph. That's not a great naming scheme at all. Maybe I should rename that to like internal graph, but let's use width and height, right? And then we'll name that internal graph, which I don't think that's stuck. Oh, it did. Okay. All right, cool. All right, so we've got that. Oh, render graph on resize can fail. All right, let's change this to a B8. And let's change this to a B8. Since it could fail, on the internal level, we should probably handle that externally. Okay. So the other thing I think I'm going to do is we're going to create this forward render graph in our testbed game state. And we're going to, every time we sort of move code from the testbed over to the render graph, we're going to replace and swap this out for what we're actually going to be doing. So let's do, why can you not find? Let's see, where do I want to put this? Probably right around the pass stuff that's still there. Yeah. So instead of yeah, those are the only, okay. So after this, these are our passes that we haven't moved yet, right? We'll probably create separate render graphs for those things, which right now are just going to consist of one pass, but there'll probably be multiple passes eventually. So what I'm thinking now is we do forward render graph. And I guess we could just call this forward graph maybe. Obviously that's an unknown type. So we want graphs, forward render graph. All right. So we have our forward graph here, which means when we do this, we're going to say forward render graph on resize, and then we'll pass the address of state forward graph, and then we'll just pass through width and height. And we weren't actually checking this for an error before, so I'm going to do that now and bleat about it if there is an error. Error resizing forward render graph. See logs for details. Get rid of that one. Let's see, do we have... Yeah, this returns void, so there's no point in booting out. Okay. So that's the first thing that we'll swap out, first and easiest. Let's see. So here's the render graph destroy. So all that's going to do is come over here. Let's see, we want to do address of graph, internal graph rather. All right, so we'll destroy that. And then here we'll do forward render graph destroy, passing to it the address of state forward graph. Sergel? I'm not sure how to pronounce that, but thank you for the follow. I appreciate that and welcome. Let's see. Okay, so we've got that one moved over. The next thing that we're going to do is refresh render graph pointer functions. PFNs. We might not actually need this anymore. Because what this does is whenever we hot reload the game library, we also have to hot reload, or update, I should say, these function pointers, because their address won't be valid anymore. But since all of this and its passes are moving to the core, we technically don't need to do this anymore. So I think what I'm going to do is I'm going to pick out the skybox pass, shadow map pass, and the scene pass, since those are the three that we have. And I'm I'm just going to plop them in initialize for right now. And obviously we'll have to fix some of the issues there, but that's where I'm going to put them for right now. And configure render graph, this is what we need to really look at, right? So, and we might need to extend our render graph a little bit too to be able to pass resources from one render graph to another. Maybe, right? We could also just get them this way as well. Maybe if we have render graph dependencies or something, we can do that, which is another to-do on the list, right? So we might wind up having to handle that as well. Singyi, hello, welcome. Good to see you. So, all of this definitely qualifies as initialization, right? So, we are going to rename this stuff a little bit, but I'm basically going to take everything up to the scene pass and plop it in here. Oh, we don't have the logger, do we? We do not. So we want core logger, right? Why does our render graph need the application? I don't remember why we did that. So we have the app. That's hilarious. Okay, we've been passing it that whole time. We never actually needed it. Never wound up using it. It's literally taken in, set here, and then destroyed there. Works for me. I must have been thinking we needed it for some reason. Application types I think can go as well. We want to do application, that can go. And I don't think we need that anywhere else. Which likely means we can get rid of that. And we can get rid of it from the declaration. Right. Okay, so that's that. So we don't need this anymore. And then this is going to be graph, internal graph. Okay, so that's that. Time for a walk. Good luck. We'll catch the VOD later. Awesome. Well, thank you for stopping by. Appreciate it, and see you. See you later. Let's see. Hey, very first time I get to watch a stream. Glad I could make it. Love what you were doing and the community around it. Awesome. Glad to have you here and welcome. Yeah, my schedule is kind of hectic sometimes because of other commitments, right? But I'm working on that, right? I know the time I stream is a little bit weird sometimes, but you know, I'm working on some things. I got some stuff that maybe I might be able to do something about that. We'll see. But worst case scenario, the VODs are always there, right? But welcome. All right, so I think the state frame graph is going to be repeated a lot, and I'm wondering, you know what? I'm just going to do a find and replace on it now. I might have to do it again later. So let's see. It's going to be state frame graph. and we want to replace that with graph internal graph. Cool. All right. So we're also going to have to include all the stuff about our different passes that we have. So we're going to need to do that. Speaking of which, we can actually take some of those passes out of here. So we have scene, skybox, and shadow map pass. So let's actually do, let's just grab this. Wow, it did not copy that the way that I thought it should. Let's try it again. There we go. Passes is under the renderer, I think. Oh, wait a minute. I don't think we made that to the core yet, did we? Or did we? Shoot. The only one that's part of the core is the shadow map pass. So would we leave the others in testbed? I bet I did. Yup. Which now has me thinking, did we also... Yeah, simple scene is there too. Okay. Well... This just got a little bit more complicated. I mean, not terrible. We just have to move some stuff around. Not a huge deal. So some of these standard things like the scene pass, the skybox pass, and then this stuff under resources for simple scenes all needs to be moved to core. I was thinking that those were going to be like application specific, but the more I thought about it, it doesn't really make sense to have them that way. And we also need to rename simple scene because it's not just going to be a simple scene anymore, right? It's just going to be scene, I think. Because it's going to wind up doing a whole lot of other things that initially I wasn't going to have it do. Okay. So how do I want to do this? Can I? Yeah, I didn't think I was going to be able to. I'm going to have to do these one by one, or I could just open an Explorer window and do it that way, which is exactly what I'm going to wind up doing. Let's see. Why is my window quite so massive? All right, let me just browse to the folder here for a second. Okay. There we go. All right. So, what we're going to have to do is we'll go into testbed lib and source, and I want to take passes. And we're going to go into engine, source, renderer, and plop that down, right? And that should merge the passes in there. Oh, editor pass shouldn't have gone with that. Because that is kind of specific. Well, yeah, it really doesn't belong in the core. It doesn't belong in the application either. It belongs in the editor, but we don't have an editor yet. So let's do Oh, okay. I just copied it. I didn't cut it. Perfect. All right, so we'll leave the editor pass there. Resources, however, we have the simple scene and then the loader for the simple scene. So this whole folder can get cut and go into the engine source resources. Really, Windows? You can't just merge the... You can't just merge it? I really need to switch back to Linux. Okay, so resources. I guess we're just going to have to do this. And then engine. Source. Resources. Put this here. There we go. So you could merge that folder, but not the parent folder. I don't understand, but okay. It is what it is, I suppose. What does the skybox pass do? It renders the skybox. That's literally it. The reason it's got a pass of its own is because the skybox doesn't use the depth buffer. It doesn't need it. In fact, it's all that stuff's disabled. So we don't test it. We don't write to it or any of that stuff. And so what we do is we render the skybox first, and then we render the scene over top of that. And that's more or less the way we do it. We might be changing that in the future, but because of the difference in attachments, we needed a different render pass for it, and so I split it out. And right now it's just a simple skybox. Eventually it's going to be a little bit more complex than that, where we have the ability to control like sunlight and that kind of thing. But for now, that's what it is. All right, so this should now have the scene pass, yes. And then this also needs to be renderer passes an included file game state. Ooh. What does it need the game state for? I'll bet it was this. So let's get rid of that. And then shadow cascade. Didn't we have... max shadow cascade count, but I thought we had max cascade count. I thought so. In shadow map pass. That's what it should be using. Okay. All right, so that should be fine. It means the game state has some weird thing in it. I don't know why we have this defined in two different places as two different things, but be gone. Okay, so we have our supported passes here. Also this. Which should also realistically be there. And then we don't really need... We do need render graph. This should probably be up here, though. Okay. So when we're adding our sources... instead of state, we are going to have graph skybox pass. RG check. Where's that defined? Not here, apparently. Did we define that in here? We did. Why did we do that here? Dunno. I guess we should take that away from here and put it in rendergraph H. I guess we can put it, let's put it towards the top. Put it there. All right, so that should fix our RG check issue. Rendergraph pass create. This is probably also going to be a state, so we need to rename that to graph. Shadow map pass. Scene pass. Going to be the same thing. And then okay. Oops. Okay, so we configure our render graph. We call refresh PFNs, which is this guy. All right, so we do that, but we do not call finalize at this point. We call that elsewhere, apparently. So instead of all of this, we're going to do forward render graph initialize. We're going to take the address of states forward graph. Right. And we'll check to make sure that this was successful. Forward render graph failed to initialize. Delete about it and return false. Cool. All right, so that's moved. Why does Vim look so hot right now? Is this what it looks like to be competent in Vim? I wouldn't consider myself competent in Vim, to be honest. I'm better with it than I used to be, but I'm competent's putting it strongly, probably. But yeah, I really do quite like it. I prefer it over any other editor I've ever used, for sure. Let's see. Will we design a RHI layer when we input mutable graphics API? I'm bad with acronyms. What is an RHI layer? I probably know what it is, but I'm not familiar with that acronym. What is a RHI layer? And what do you mean by input mutable graphics API? All right. So we've got that. Okay. This whole section here, actually, can go. That's a bunch of code that we just don't need. Okay. So I think that's configure render graph. Wait a minute. Configure render views. Isn't that the function I just killed? It's not called anywhere. See ya. Figure render graph. Okay. So we do render graph finalize in a separate call. Why did we do that? Why did we split it out? I don't remember why we split it out. We have ads while I think about it. So for those of you who are new to the channel, I pause the stream every 30 minutes for 90 seconds while we have ads, because on the Twitch side, we are given ads that often. So I don't want anybody to miss anything, so we like to pause the stream for that. And I see the chats over on YouTube side. I know you guys don't get ads quite the same way as Twitch does, but I like to just kind of keep it consistent across the board, right? So I will answer those comments as soon as we come back. We've got about 50 seconds left on ads. All right, almost done. Got about 20 seconds left. I'm gonna hydrate a little bit more, then we'll continue. All right, cool. Ads are dead. All right. Oh, render hardware interface, RHI. I gotcha. So it's the abstraction layer over several platform specific graphics APIs. We already have that, actually. I didn't call it that. But so what we have is we have a renderer front end and a renderer back end. The front end is essentially the abstraction layer that you're talking about, right? So it's what the rest of the engine interfaces with. And then the back end is actually implemented through a plugin system. So we have a Vulkan renderer plugin. Eventually we'll have a DirectX/Direct3D renderer plugin, a Metal plugin, things of that nature. And all of those implement the same interface to the renderer front end. But it keeps all of the renderer API specific stuff out of the rest of our code. So yeah, like you say there, when we switch to DirectX GL Vulkan, we don't need to change the rest of the renderer code on the upper side. Yeah, so yeah, we already have that. Like I said, I didn't call it that. But to show you where this is, so in the engine library, we have this renderer right here. And all of this that's in here is all front-end code. So we actually literally have something called the front end. Which implements a whole bunch of these function calls, right, for different various functions that we need, uploading geometry, beginning render passes, things of that nature, right? But they're in a platform agnostic sort of pattern, right? And then we have a little bit further down, we have a little bit further down than this, we have the Vulkan renderer here. And so this implements sort of the interface that this front end works with, and it contains all of the Vulkan specific stuff, right? So yeah, we already have all that in place. Yeah, I designed this engine with that in mind because I knew that I wanted to implement multiple renderer backends. So Vulkan just happens to be the first one that we're doing, but we are going to be doing Direct3D. We are going to be doing Metal. We might do OpenGL. I haven't really decided on that one yet. Just because if I have the others, what the heck is really the point, right? So yeah, that's more or less what we're doing. Yep. Aborting is spelled wrong though. Yep. Typos in logs are sometimes useful. Yes, it helps you nail down an error, right? Or where an error comes from. Yeah, I did notice that actually, but I was about to kill it. So I was like, well, it's really calling the application boring is what it's doing. Hey, a boring application. That's what we're dealing with here. No, but in all seriousness, I'm just trying to think. I'm trying to wrap my head around why I split these two out, and I don't completely remember why. And so I'm actually kind of considering just not doing that anymore, because we had the configure render graph, which also set up the function pointers, right? But then after that, and we had commented out in configure render graph. Render graph finalize. So I don't remember why I moved it. So actually what I'm going to do is I'm going to take that and plop it here. And then do that. And then graph, internal graph. And then if we get all the way here, we return true. So that just makes more sense to me. So we don't really need... Maybe it was because of this. I'm not sure. I honestly have no idea. But it's gone. So configure render graph will now do the thing. And in fact, I'm going to uncomment it here as well until we move everything over. All right. This should probably be renamed to configure render graphs, because it's going to be doing multiple. Daddy Biffles, thank you for the follow. Appreciate it. 3 a.m. in Scotland, so you're heading off. Hope to catch you on the next live stream. Well, I appreciate you being here, and especially so late in the morning, or early, late at night, early in the morning. I appreciate that. So thanks for stopping by. Good to see you. Okay, so what are the next things that we need to do? Render graph create. I'm wondering if we should actually move some of this stuff to creation. We might wind up doing that. So I'm just going to mark this as return true for right now. I think we're going to wind up kind of moving some of this stuff around in here. So we have create, destroy done. Update, frame prepare. Oh, you know what? We forgot one that's really important. We forgot to execute. That's kind of important, right? So we have execute. So we need the graph and frame data for that as well. I don't think we need anything else though. So plop that here. All right. So, update. Do we have a render graph update? I don't think we actually do. It's not found. Which I think is probably... This is what I was missing. Render graph load resources. We need that. I knew there was another step we were missing somewhere. Let's see. So load resources probably ought to go into initialize. It's got to be done after finalize. So we really realistically need to put that here. Internal graph. Okay. So yeah, what I was thinking before, this all really belongs in create. All of this stuff. And of course, these are all going to have to change to outgraph. One more. Wish I'd realized this before I renamed everything. I keep hitting N instead of B. All right. Okay. Looks like we missed one more. Okay. Cool. All right, so that's it for that. So that's create, destroy, initialize, just loads the resources now, which kind of makes sense. And then update is basically a no up for right now. We might wind up getting rid of that, but there may be passes that need an update, so we'll see. Frame prepare is where a bulk of the work is actually going to wind up being. So if we do prepare frame, basically like 90% of what's in here is going to need to be moved over. Is this forward or forward plus? Right now it's forward. Yeah, so forward plus is coming. It's on our to-do. Right? So we have deferred rendering and forward plus on our to-do list. So what I'm doing right now is we've basically, in our application, configured a forward renderer by using our passes and stuff the way that we're using them with our current configuration. And so rather than kind of destroying that setup that we have now in order to create deferred rendering and forward plus and all that, rather than doing that, I'm going to move all of that stuff and that whole configuration to sort of this specialized render graph, this forward render graph. So that way, all you have to do is basically say, I want to use a forward render graph. You just get all this stuff with it, right? And so it's sort of like a pre-configured render graph, if you will. Hope that makes sense. Okay, so I guess I'm just going to start highlighting, right? So all of this is all the logic for like grabbing all of our stuff for the shadow passes, the scene pass, which some of this we probably could clean up a little bit as well. Debug geometry. So all this stuff, all the way to here. Wait, is this the... This might actually be too much. This is the editor pass. Okay, so we don't need the editor pass. We just need the scene pass stuff. So let's snip that and snag that over here in the frame prepare. And we're likely going to be missing a lot of data that we have to get, right? So we'll go ahead and figure all that stuff out. But yeah, you can see already, like, this function is a lot smaller already. So essentially what we're going to wind up doing here is, instead of doing all that other stuff, which actually I need this back, because the editor pass shouldn't run unless there's a scene loaded as well. So basically in here we're going to say forward render graph frame prepare. And we're going to pass the address of our state forward graph, and then we're going to pass through pframe data for now. We're probably going to have to add more parameters to that. And then, of course, we're going to negative check this and bleat about it. Failed to prepare frame data. Right? And we're basically just gonna call this no matter what, always, right? Okay, so we now kind of need to figure out, like, some of this we need a little bit more generic data to sort of work with. Instead of, you know, sort of the hard-coded scene test stuff, right? So it looks like there's going to be a lot of things we're actually, even right here at the top, that we're going to have to address. So there's that. So it looks like we're going to need... We'll fix this first. We'll do graph. And then the pass data itself is all just going to be graph. All right. Okay. So current camera is being passed through as state world camera. Obviously, we don't want to do that. So we need a camera and a viewport. So we'll do pframe data, and then we'll do const struct camera, current camera, and then we'll do a const struct viewport. Oops. World viewport. I don't know if I want to call it world viewport. I guess I could just call it current viewport. There's a lot of things that could be. And then we'll need to do... what was that under? Math? Or was it resources? Where did I define the... Oh, it might be graphics types or renderer types. Might be render types. Yes, we have... Oh, no, where's... Okay. I don't remember where that's defined off the top of my head. Render a viewport. I could have swore I checked that. Okay. Is what it is. All right, so we have viewport. We need camera, which is under resources. I thought. Is it not? Oh, it's under camera, or renderer, rather. It's been a while since I've looked at those files. Okay, so... Oh. Okay, there we go. Might help if I actually typed it out correctly. Strange Zach, thank you for the follow. Appreciate that. Let's see. Zaka6. I managed to survive my first ever JSTS exposure. Got LSP client working. Nice. That's awesome. It's super satisfying when you finally do get that to work, isn't it? Apotham, how's it going? Good to see you. Nice to see some more work on Kohi being done. Yep. Yeah, we're constantly doing stuff. I do stuff off camera too, so I did some stuff off camera as well since the last stream. So there's that as well. But yeah, we're constantly moving forward on it, right? I'm trying to like gear towards getting things done that are going to get us closer to being able to make a game. The JSON configs are crazy over there. Yeah, I believe that. JSON is one of those languages that can be awesome, but until you have like a really, really large file, and then it's not so awesome. All right. So that should do for now. So we don't want this anymore. We instead want current viewport. Oh, does this just need a copy of it? No. Oh, it doesn't like the const. Why not? All right, fine. Fine, UN. I'll get rid of the const. All right, camera, current camera. We can actually remove that. We don't need that. So the camera view get is from current camera, which is now passed in there. Let me guess. It doesn't want it. Oh, okay. So the current camera can't be const because this view get will regenerate its view matrix if it needs to. So that can't be const either. That's what I get for trying to be const correct, I guess. Okay, so we have that. The projection matrix is going to just be current viewport projection. All right. Now, here comes the tricky part, because there are a couple ways to handle this. So the first way to handle this is we pass in a pointer to the scene that we're going to be essentially rendering. And essentially what we would do is call this forward render graph on each scene that we have. And the only problem that I really see with that is if we ever plan on having more than one scene loaded at a time. Which we could just say, you only ever have one scene loaded at a time, and that's that. But what if we wanted to have something like multiple scenes that load and unload as you go through parts of a game, right? We don't want to necessarily, I guess, force us to have a specific object hierarchy to support that, right? So the question then becomes, do we iterate all of these scenes, if we have multiple scenes, check each one if they're loaded, do these passes against each one of those individual scenes in order. And then the problem also becomes something like a skybox you can only really have one of. So you wouldn't really want to render multiple skyboxes, would you? This is an interesting design conundrum. Let's see. Making a game the ultimate goal of making an engine. Exactly. Yeah. Otherwise, what are we doing, right? I had to do some work in CPP today for the first time in 10 years. It really made me remember why I switched to C. Yeah, exactly. I think the same thing every time I use C++. C is so much better. I use C++ in my day job, and it's been so nice when I come home and write C. Especially when the C++ code base is Unreal. Been there, done that. CPP is beyond dog shit at this point. I literally left games so I could write C at work all day instead of CPP. C gang, yep. Yeah, I mean, we're definitely all C gang in here for sure. I mean, I'm not going to poo-poo other languages, right? I think it's overcomplicated for what it is. I think it's bloated, but it still has its place. A lot of people use it, right? So it's my preference not to, but I'm not going to poo-poo it. You will poo-poo other languages, though? Yeah, no, that's totally your prerogative. I don't... The thing I'm trying to avoid is I don't want somebody coming in and potentially feel bad for having chosen to use C++, right? Especially if they're still learning in the early learning phase or something like that. That's what I'm trying to avoid, right? So I try not to poop on things like that, but yeah, you know, I definitely have my preference. Your buddy is making a modern C++ game engine, and he had you write the OpenGL part. I did not enjoy my day. Yeah, oof, yeah. WASDFX, first time chat, welcome. C is just cozy in my opinion. People get scared of seg faults and memory issues, but they're not as bad as people make them out to sound in most cases. Exactly. Yep, I agree. What is it? HR Okami? I appreciate the follow. Thank you. You're over there writing your game in Rust. You know what, though? I mean, like, if that's the language you know and that you're familiar with and you like it, roll with it, right? I've written games in JavaScript. So, you know, you got to do what you got to do. Only ECS gets hate here. Yes. But I'm still going to wind up writing one anyway. But yes. Well, there's that, and then there's also that which shall not be named. No, I'm just kidding. But yeah, entity complication systems are the only thing that gets a little bit flamed around here for sure. Okay, so I guess the real question becomes, do I want to rewrite this to just kind of handle multiple scenes, and if I never use it, I never use it? I think that's the most flexible option, because then if somebody wants to use multiple scenes, they can do that. So here's what I'm thinking about. So when will you need support for multiple scenes? Here's what I'm thinking. So let me launch. I know it's bright. Give me a second here. Fix that. All right, there we go. So here's what I'm thinking, and you see this on console games a lot, right? You've got this big open. Why am I not? Is the line really that thin? Why am I not drawing? Really? Oh, because it's a background color. Skill issue. Okay. So, in a lot of games, you've got this huge scene, right? That's, got all kinds of stuff in it. And ultimately, it comes up to a point that looks something like this, right? And then you've got, like a scene B over here that's got all kinds of stuff in it, right? And it's got something like this, right? And then maybe we have ads. So yeah, that was poor timing on the ads. We'll finish that explanation when the ads are done. So for those of you who are new here to the stream, we pause the stream whenever ads come up so that nobody misses any content, because if ads are up on the screen, you guys can't see what I'm talking about and you can't hear it, right? So I like to just go ahead and pause it so that nobody misses that, right? So it's up to 90 seconds of ads every 30 minutes. So it's not that long. Gives us a chance to sort of take a break. Gives me a chance to hydrate. Gives you guys a chance to go grab some water or something. If you guys aren't hydrating, do it. Right? Just a lot better of a thing to do. All right. So we got about 20 seconds left on ads.
Spired one lurk.
Almost done. All right. Ads are dead. Cool. Smudge, thank you for the resubscribe with Prime there for 4 months. That's awesome. I appreciate the support there. Thank you. Okay, so yeah, so the thing that I was talking about is we have these multiple areas in a game world, right? Where you have these different areas that have got all sorts of like complex sort of geometry in them. They've got lots of objects all around and stuff like that, right? And then you'll sort of step into this this kind of corridor that sort of bends around like this, right? And you sort of have this kind of thing going on. And like the same thing will happen here, where there'll be like a bunch of objects or something, and you have to sort of squeeze between some cracks and rocks or something like that. And so the whole idea that happens here is these are used to transition from one scene to another, typically, right? Or one area of the level. So if you're moving this way, right, then what's going to happen is this, when you get to about here, right, what's going to happen is you can no longer see this level, right, because your vision's cut off about there. So this level gets unloaded, and as you make your way around here, this level gets loaded, right? So by the time you get here, you're loaded up. And then what'll happen here is kind of the same thing. You'll get into this little corridor that takes X number of time, right? And once you go around this corner, that goes away, and this one starts to load up, right? And so by the time you round this corner here, this will be loaded up and ready to go. And so my thought process for multiple scenes would be, this would be a scene here, right? This would be another scene. This would be another scene. This would be another scene. And this would be another scene, right? And you may have multiples of these loaded. Typically speaking, you'll have up to 3 loaded at once, the way I see it. And so you may actually have, this number 2 scene here might be loaded. You're loading in this one, and this one is unloading, right? Or maybe hasn't unloaded quite yet. And so this is where I could see multiple scenes coming into play. It's just a situation like this where you need to seamlessly sort of switch between one area to the next, but you can't afford to have all of this, and all of this in memory this is generally what you would do. Yeah, so let me just catch up in chat here. Let's see. Adds in your terrain. Nice. Turbo Gang. Yep, I have Turbo as well. You don't even have a PS5. Thanks, Twitch. Suicide Squad's garbage ad. Oh, okay. Is that what's playing now? The way I like doing this, by the way, is having a world that consists of levels. Multiple levels in a world is fine. I just didn't know what that's what a scene was. Yeah, so a scene is essentially a level, right? I just call them scenes instead of levels. It's really just an interchangeable term. Let's see. More complex world streaming is done usually, and it can be done in a single scene. So it can be done in a single scene, yes. We could have like a hierarchy of objects to manage this as well. And so that's certainly another way to accomplish it. It's just the question is, do I want to force that or not, is really the question. Trash Can, hello. Good to see you. Welcome to the stream. This can be done by loading the prefab. That's what you mean, just stream prefab chunks off the map. Yeah, so you could either use chunks in that regard, or you could define them as like hierarchy objects or something and do it that way instead of multiple scenes. That's certainly a way to do it. I suppose if we needed multiple scene support, we could always build it in later. So maybe I'll just go the simple route for now. Let's see. What about huge worlds? Might you use scenes for the tile of the huge world? Don't most games split up levels into sublevels for culling? Potentially visible. Potentially visible splits. Okay, so the way that if you're thinking of like an open environment, like Grand Theft Auto or something like that, level of detail is used like hardcore in that. Like the stuff you see all the way in the very distant background is like planes at best. And what they do is they just stream in the levels of detail on the individual objects, and they're constantly streaming things in and out. That's the way that works. So that's a very different and far more complex system than what we're talking about here. Some games do this kind of style, like the most recent God of War, I'm pretty sure does this under the hood, right? So it all depends on the requirements of the game. If you have an open world, like this won't work for an open world. But yeah, you could do it with prefab chunks of the map. It really depends on what the requirements of the game are, right? So I guess instead of doing these as scenes, they could just be, like a hierarchy of objects, and we could just say that, right? Jack and Daxter, yeah. So maybe that's what we'll do. We'll opt for the simple approach for now, and add the complexity if and when we need it, right? Maybe Kohi 2.0 will support that. No ECS currently? Definitely not. Nope. So ECS will not be a core part of this engine whatsoever, because ECS, I call it entity complication systems, because it typically does just that. It adds a lot of overhead and things that you don't really need, especially for simpler projects. I would argue that a lot of smaller indie games do not need an ECS, right? For larger, more corporate projects, sure, but most projects don't actually need it, right? Because the only thing that ever has any sort of hierarchy is transforms, right? That's ultimately what you want, right? You want transform hierarchy. You don't necessarily need object hierarchy for that. ECS is a relational database for hundreds of objects. Kinda, sorta. Tech 256 for the raiding party of 22. Welcome. Thank you so much for the raid. What are you up to tonight on stream? I'm going to toss you a shout out real quick. So definitely toss Tech 256 a follow. I just tossed you a follow as well. What were you up to on stream tonight? working on porting a Win32 C++ game to Linux. Normally you just work in C, etc. Awesome. Well, that sounds right up my alley, for sure. Yeah, I definitely tossed you a follow. That's what we like to do here. We like to work in C here, for sure. So welcome, Raiders. Let me give a quick intro as to what we're doing. And then I'll sort of catch you up to what we're currently doing. So we are working on... Oops. Dang it, Windows, cut it out. All right. We are working on what is called the Kohi game engine. And so this is a game engine that we're building from scratch using C and Vulkan as our initial rendering backend. I say initial rendering backend because this is designed in such a manner where we can have multiple rendering backends. So we have in the plans Direct3D and Metal and maybe even OpenGL. And the engine's designed in such a way where those things are just plugins to the engine. As is like our audio system, our physics system, eventually our ECS, things like that are all plugins to the engine. The whole thing's being designed with a modular approach in mind. So the series started off as sort of a YouTube tutorial series, but it quickly sort of morphed away from that once it kind of gained a little bit of size. And we changed formats for a little bit, and ultimately we wound up landing on the live stream format that you see here. So we stream on Twitch and YouTube simultaneously, and that's just kind of where we're at now. So the engine itself is cross-platform, so it runs on Windows, Linux, and Mac OS natively. Mac OS is actually making use of something called Molten VK to get it to work with Vulkan, but it does run on Mac OS. It is royalty-free, so it is 100% free and open source. If we go here to the GitHub page, it is Apache 2.0 license, which basically says if you use it, you can use it for anything you want. Personal, commercial, doesn't matter. The only thing that I ask is just say you used Kohi. That's literally it. There will never be any sort of royalties. There will never be any sort of licensing fees behind any of this. It's always going to be 100% free and open source. Additionally, any sort of the links that you see here, like on the Patreon or on the YouTube, in terms of support, those are purely optional. My YouTube channel is considered an educational resource, same with the Discord. I don't paywall any of the content. I believe education should be free. I believe this knowledge should be free. And so we're showing a way to build a game engine. It's not necessarily always the way that you're going to want to build a game engine, because there are certain things we have to do for the educational purpose of it, right? But the idea is that this shows a way of building a game engine. And we talk about the strengths and weaknesses of the different things that we try as we go. And so, with that in mind, we don't paywall anything. It's all 100% free. So any support that you do give is greatly appreciated, but it's completely optional, right? So if you like the work, feel free to support it. If not, that's cool too, right? Just you being here and tossing me the follows, which thank you very much for the follows, by the way, that supports me, right? So yeah. Cool. All right. So let me catch up on chat here. Thank you guys very much for the follows, by the way. Let's see. You were lurking here, then went to Tech 256 and just got back once again. Awesome. I love when that happens. Oh, you've watched quite a few of the streams. Awesome. Okay. Well, welcome again. I'm glad to have you here. With how things are going in some other game engines, you might want to consider adding a no runtime fee in that statement of no fees. Yeah, I probably am going to revise the verbiage to just say no fees of any kind ever. Period. Right? Because it's free and open source, right? What's really hilarious about that is when I started this project, I had it in mind that, knowing how to do this stuff keeps you from being beholden to these large corporations that own these engines, right? And I was like, if any of them ever change their license agreement or something and, whatnot, you'd be screwed. Like the machinery just shut down. They're like, you can't use this stuff. You have to delete it. Anybody that was using that engine had to delete it. The whole Unity thing, that whole debacle that happened several months ago. And, by the time that stuff happened, this engine was already like 2 years in development. But It's just that kind of stuff that just illustrates and underscores my point of it's always good to know how to do this stuff, because then you're not beholden to anybody, right? Let's see. Yeah, the machinery thing was absolutely nuts. And that was a real shame, too, because that was really coming along nicely. You got into making game engines purely because your mom was literally unable to buy you a Game Maker Pro when you were 12. Yeah, I get that. I totally get that. I still can't believe they just refunded the licenses and were like, delete your copy. Yeah, that's completely bizarre. Had to make games no matter what. Yep, I get that. Yeah, the first game engine I ever actually owned was the Torque game engine when they were selling it for $100 back in like 2001. They seemed like nice guys though, the machinery. Yeah, they did seem. I suspect that there might have been some aspect of the tech that maybe they used that wasn't licensed properly, and they got taken to task over it. I'm wondering if that's what happened. Because for them to just like randomly shut down like this and be like, you have to delete your copy, you can't use it. It's a little bit weird. They sold their other engine to Autodesk. Yeah, I forget what that was called. I can't remember. But yes, I do remember reading that. That whole Unity thing is why I got stuck writing OpenGL and CPP today. Yeah, I mean, yep, a lot of people are making that decision, right? Of course, there's some law issues. Yeah, something legal happened there for sure. Maybe they shared some code. Yeah, exactly. You still have one of their beanies at least? Does that make me cool? Yeah, I don't have one of their beanies. He used to always give me crap for wanting to write my own engine, but he sure changed his mind. Yeah, exactly. A lot of people used to give me grief over that too. They're like, why are you writing your own engine? That's so stupid. Is it? Let's see. Okay. I think. Yeah, who's laughing now? Exactly. Exactly. Bit Squid, that was it. Yes. I knew it had a weird name. I couldn't think of what it was. That is a throwback. That's like thinking about renderware. You want to talk about throwbacks, renderware. Same. It makes me feel old too. But yeah, so yeah, we have, I didn't drop the link to this. So I'll drop a link to chat. The website that has all this information is kohiengine.com, right? So we do also kind of loosely maintain some documentation. So like our source code is actually fully documented in here. So, you can go in and, let's see, what's a good example? Let's look at DRA, for example. Right? Just kind of auto-generated documentation, but all that stuff is here as well. So, yeah, I hope all that makes sense. And yes, there we are. And waving to myself, right? Reminds you of JavaDoc. Yeah, so this is Doxygen, which is basically where JavaDoc, I think, essentially came from, at least idea-wise. Doxygen's been around forever, but it essentially just analyzes the code base and picks out the comments from the code base and builds this. Yeah. All right. So what we're doing here is we are, up to this point, our sort of test application for this, which is known as testbed, go figure, has contained the configuration for our forward render graph, right? So we kind of set that up in just the sort of test application that we have. And I got thinking, I'm like, well, we have some other types of render graphs we're going to be creating, right? We're going to do deferred rendering. We're going to do forward plus. And so I'm like, we should probably wrap up this configuration into a specialized render graph. So we're doing that tonight. So we're creating the forward specialized render graph now. We've got a few more things I want to add to that, and then we're probably going to move on to the deferred one somewhat soonish. And that's just kind of what we're doing now. So I just moved this code out of the application code, and now I'm just kind of fixing all the references and figuring out what we need to pass in to this frame prepare. So this is basically called once per frame, and this gathers all of the data that the renderer is going to need to draw the frame. And then when we do execute on the render graph, it basically goes through all of the passes that are hooked up on the render graph, feeds them the data that was gathered here, and then goes ahead and reaches into the renderer and performs all the drawing tasks and all that stuff. So that's more or less what we're working on at the moment. So we do have something right now that's called Simple Scene, which we're actually going to be renaming the more I think about it, because it's basically just going to be Scene, I think. Resources, Simple Scene. The original idea behind Simple Scene is that it was just going to be a simple container that held a bunch of things like meshes and terrains and debug objects and other kinds of lights and that kind of thing, without any sort of spatial partitioning or anything like that. But the more I thought about it, the more I just kind of went, why don't we just make a scene? And if we want a simple scene later, we can kind of derive one, but it didn't really make a whole lot of sense to me. So we're going to do struct simple scene. And since it's not a simple scene anymore, we're probably just going to rename it to scene or something. But for now, we'll feed this in as scene. Then we'll do we'll check the scene state. Okay. So we do have some stuff here regarding the editor gizmo, which doesn't really belong here. So let's actually move that back to the editor pass. I guess we can put it here. It's more or less the equivalent of where it was before. So the skybox pass doesn't need very much configuration at all. So the first thing that we'll do, I guess before we even do that, is we'll do scene. So we'll do a render frame prepare on that. Does that? That's return type void. Okay, so that's fine. Skybox pass. All right. Whoops, did I accidentally? Yeah, I accidentally closed it. Not Skybox. Brain fart. What was the file I just had open? Forward. Render graph. There we go. Let's see. Oh, Roberto, thank you for the super chat, the 99 cents. Appreciate that. I appreciate that. Yeah, the super chats aren't something I see very often, but over on the YouTube side, that's kind of cool to see that. So I appreciate the support there. Thanks, buddy. Appreciate that. Tamman, good to see you. Twitch didn't notify you. Well, how rude of Twitch. Good evening. I'm doing well. How about you? Hope you're doing all right, Tamman. Good to see you here. All right. So this is the skybox pass. So all we really need to do for this is grab the skybox out of the scene, right? So it's literally just going to be scene skybox. And then we do a whole bunch of other stuff that we're going to kind of need. This is all kind of prep and preparation for the other passes. But you know what? I think I'm going to move this down here. And then I'm also going to put... Oh, wait a minute. You know what? Did we... Yeah, that should be fine. Okay. So the skybox pass always gets rendered, but it only gets assigned to skybox if we actually have a scene loaded. Otherwise, it does not. And then we do the shadow map pass after that. But before we do all of that, we have a whole bunch of global stuff that happens up here first. So global setup, we'll call it. So the view camera. View camera, do we actually need that to be separate? I don't think we do. I think we probably get away with just using current camera instead of that. So let's clean that up. Viewport is probably going to be the same thing. So let's do current viewport. Oops. Viewport. And then we have a whole bunch of checks here for like the scene directional light, right? We have that sort of repeated a bunch of times here. So we should probably like eliminate some of that repeated code. Doing fine. What are we working on tonight? So tonight we're actually, we're taking all of the render graph stuff that we've done up till now. And since we've sort of configured a forward renderer, we're putting that in a forward render graph, specialized render graph type. And the reason we're doing that is because we want the ability to have different configurations of render graphs. So this is going to be one of those configurations. So we're just getting all of that config out of the testbed application, moving it over to here because typically speaking, your forward renderer is going to be the same no matter what you're doing, right? And the same is going to be true for our deferred renderer and our forward plus renderer when we implement those. And so I figured putting those, that configuration and setup and all that stuff in a more specialized container like this makes sense because that gets all of that logic out of the application, and the application could just say, hey, forward render graph, do the thing. And that's it, right? So it kind of keeps things simpler that way. Okay. So I think, a lot of our setup here relies on the existence of a directional light, right? If we don't have a directional light, like there's some of this stuff just doesn't even make sense to run. But we're kind of like repeating ourselves a lot here. So we want to do away with that. So what I'm going to do is directional light pointer, and we'll call this dir light, right? And we're going to say that dir light is equal to current scene, or what was that? Scene, I think it was. Scene directional light, which is also a pointer, right? Oh, I don't want to do that as a struct. I probably just need to include that. Let's see. Include, it's not in renderer types, resources. Or is that lighting system maybe? Maybe? Yes. Okay. So we'll grab like a convenience pointer to that. That way we could just say, if we have a directional light, use its shadow distance plus its shadow fade distance. Otherwise use 0, which is probably not the best default value, but it is what it is. I don't recall, is RenderGraph config done on a separate file or is it programmatically? So it's programmatic for right now. I think One of the goals is to eventually be able to have a render graph that you configure in like a text file, but we don't have that yet. But at this point, we don't really need it either because we're just kind of still figuring some things out in terms of how that's going to work. So I figure once that's nailed down, I'm thinking probably once we actually create the deferred renderer and then the forward plus, we'll know enough about how these things need to be structured that we can then set up a configuration for that and load it via configuration. So like if the application has a separate type of pipeline it wants to implement, it can do that. We have ads. So for those of you who are new to the stream, we like to pause the stream whenever ads come up, particularly on the Twitch side. The YouTube side, ads work a little bit differently, but on the Twitch side, we are served ads once every 30 minutes for 90 seconds. I just don't want anybody to miss any content. So we like to pause the stream whenever that comes up, and yeah, so that's what we're doing now. It gives a chance to hydrate, which you guys should also be doing if you aren't already, and also a stretch, yes. Exactly, right? So it gives me a minute as well. All right, we got about 35 seconds left on ads. And then once the ads are done, we will move on. All right. All right. So I'm creating a new branch for this because I just realized it is 11 o'clock and I do have something in the morning I have to be up early for. So unfortunately, I'm not going to be able to continue much longer tonight, but I do want to at least get this code checked in. So we're actually going to wind up picking this up in our stream tomorrow. We'll pick up where we left off. But I want to get this stuff committed here so that we can see the difference between what we've done tonight and what we may do tomorrow. I may be able to do some off-camera work as well. Because really what I'm doing right now is just kind of moving stuff around, right? Add. So this is everything we've changed tonight so far, which is no small amount of things, right? Commit. Work in progress. Render graph. Forward. Render graph. Right, and I'll push this up as well. Oops. Forward render graph. Right, cool. So that's pushed up if you guys are interested in that, but it's not going to compile, right? It's full of errors. So we are going to definitely pick this up tomorrow. Let's see, if in my engine I allowed the user to customize the default graph from the client code. Currently it's implemented for the ECS graph. Yeah, so we may wind up doing that. I'm hoping for a little bit lower barrier to entry on this, right? The last thing I want to do is tell a brand new user of this engine that in order to use it, that they have to set up a render graph when they know nothing about how the passes are set up or any of that stuff, right? I want to have like some defaults, some reasonable default pipelines in place so that those things can be used. Let's see. Just found out you can use YouTube Premium for a month of membership on a channel. Really? Well, I appreciate that. Thank you. I didn't know that was a thing. I have to go and look that up. That's pretty cool because I have YouTube Premium because I use Google Music and YouTube Premium comes with that. So yeah, that's good to know. I appreciate that. Oh, if the user doesn't want to do it, they don't even have to touch the graph. Exactly. Yeah, that's kind of what I'm going for here. Is like there'll be some defaults in place if they don't want to use it. Right. Okay. Let's see. Who am I going to raid tonight? Let's see. Oh, it's a feature being trialed in parts of the world, but you're not too sure. Okay, that kind of makes sense. Let's see. Let me look up. You know what? I think only because I have something in the morning and I can't stick around anyways. I think I'm gonna raid Ferret Software tonight. Simply because it's a good cause. It's basically a ferret rescue run by Pirate Software here on Twitch. And all of the ad revenue for it goes to the medical care for the ferrets. These are ferrets that have been in neglect and abuse situations. A lot of them were basically at death's door, and they have rehabilitated them, which is very, very, very expensive. And I think it's a really good cause. They've got like 21 or 22 of them now. And it's a good cause, and I like to support it in any way that I can. So just you guys having the stream open helps them pay those bills, literally. Like, you don't even have to sub or anything. Like, literally the ad revenue is enough to cover it. So I think it's a great thing, and yeah, that's what we're going to do tonight. Appreciate you guys being here, and I will catch you guys tomorrow. See ya.